The function ln of a of t over a equals kt models the amount of a particular radioactive substance that remains after t hours, where a is the initial amount of the substance, k is the rate of decay. And so a of t would be the total amount when all is said and done. If 24 grams of the substance decay to 8 grams after 36 hours, after approximately how many hours would the initial amount have been reduced to a half? Ugh. All right, so this is going to be gross. This is going to be really gross. 24 is what I start out with. So A is going to be 24. All right. My amount after 36 hours, so T is going to be 36. My total amount is going to be A of T is 8. My job is to find the rate so that when I do find the rate, I can do part 2 here. So I'm kind of doing 2 of these problems in one, which means I'm probably going to have to whip out the calculator twice. NBD, as the kids say, NBD. ln of A of T is going to be ln of 8 over A is 24 equals K times 36. So this is what I'm going to do in my calculator. In my calculator, I'm going to type this guy out. Okay, I'm going to type that guy out right there and get some gross number. Once I get that gross number, I'll have 36 equals K. I'll divide both sides by 36, and then K will equal something brand new. So one more time, I'm going to run to my calculator and find out what ln of 8 over 24 is, get a number, divide that number by 36. That gets me K, which is going to be my rate of decay, something that I'm going to need in order to do part 2 here, right there. Right, ln, there you are, of, what was it, 8 over 24. So let's type that out. It's going to equal a gross number. There it is. Take that number, divide it by 36. And our K is going to equal negative 0.30517, blah, blah, blah. So we'll actually use all of those numbers until we hit that double zero, just to keep things as accurate as humanly possible. All right, so after doing that, we got a pretty gross number, negative 0.030517. Then it was like 008, but I'm going to stop right there. Now that I know K is that, I can go back to this original equation to answer part 2. Part 2 says, how many hours would the initial amount have been reduced to half? Okay, so ln of, now remember the original amount was 24. I'm no mathematician, but half of that is 12. My job is to find T. I now know what K is, so negative 0.030517 times T is going to help me do that. So very similar to what I did over here. I'm going to type this guy into my calculator. When I type this guy into my calculator, I'm going to get a gross number. Then I'm going to divide that gross number by another gross number, which is this guy right here. And when I divide that gross number by a gross number, I get a gross number which represents how much time it takes for this substance to get cut in half. So let's go away and do that again. Right, so this time I'm going to take ln of 0.5 or a half, however you want to write it out. Right. Hit enter on that guy, and it's going to give me that number, who cares? Negative 0. Who cares? What I'm going to do is I'm going to divide that number by negative 0.030517, hit enter, and I get something to the tune of 22.713, blah, 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 blah. So let's go back, write down our final answer. We can be done with this terrible problem. All right, so after we did that, we ended up with 22 point, we rounded it to 713. It was like 7134 or whatever. So 3 decimal places is standard for AP, so we'll go with that. Gross.